Limestone is a sedimentary rock, composed largely of the minerals calcite and aragonite, which are different crystal forms of calcium carbonate. Most limestone is composed of skeletal fragments of marine organisms such as coral, forams and mollusks. Limestone makes up about 10% of the total volume of all sedimentary rocks. The solubility of limestone in water and weak acid solutions leads to karst landscapes, in which water erodes the limestone over thousands to millions of years. Most cave systems are through limestone bedrock. Limestone has numerous uses: as a building material, as aggregate for the base of roads, as white pigment or filler in products such as toothpaste or paints, and as a chemical feedstock for the production of lime. The first geologist to distinguish limestone from dolomite was Belshazzar Hackett in 1778. Description: like most other sedimentary rocks, most limestone is composed of grains. Most grains in limestone are skeletal fragments of marine organisms such as coral or foraminifera. Other carbonate grains comprising limestones are ooids, peloids, intraclasts, and extraclasts. These organisms secrete shells made of aragonite or calcite, and leave these shells behind when they die. Limestone often contains variable amounts of silica in the form of chert or siliceous skeletal fragment, and varying amounts of clay, silt and sand carried in by rivers. Some limestones do not consist of grains at all, and are formed completely by the chemical precipitation of calcite or aragonite, i.e., travertine. Secondary calcite may be deposited by supersaturated meteoric waters. This produces speleothems, such as stalagmites and stalactites. Another form taken by calcite is oolitic limestone, which can be recognized by its granular appearance. The primary source of the calcite in limestone is most commonly marine organisms. Some of these organisms can construct mounds of rock known as reefs, building upon past generations. Below about 3,000 meters, water pressure and temperature conditions cause the dissolution of calcite to increase non-linearly, so limestone typically does not form in deeper waters. Limestones may also form in lacustrine and evaporite depositional environments. Calcite can be dissolved or precipitated by groundwater, depending on several factors, including the water temperature, pH, and dissolved ion concentrations. Calcite exhibits an unusual characteristic called retrograde solubility, in which it becomes less soluble in water as the temperature increases. Impurities will cause limestones to exhibit different colors, especially with weathered surfaces. Limestone may be crystalline, clastic, granular, or massive, depending on the method of formation. Crystals of calcite, quartz, dolomite or barite may line small cavities in the rock. When conditions are right for precipitation, calcite forms mineral coatings that cement the existing rock grains together, or it can fill fractures. Travertine is a banded, compact variety of limestone formed along streams, particularly where there are waterfalls and around hot or cold springs. Calcium carbonate is deposited where evaporation of the water leaves a solution supersaturated with the chemical constituents of calcite. Tufa, a porous or cellular variety of travertine, is found near waterfalls. Coquina is a poorly consolidated limestone composed of pieces of coral or shells. During regional metamorphism that occurs during the mountain building process, limestone recrystallizes into marble. Limestone is a parent material of molluscal soil group. Classification. Two major classification schemes, the Folk and the Dunham, are used for identifying limestone and carbonate rocks. Folk classification. Robert L. Folk developed a classification system that places primary emphasis on the detailed composition of grains and interstitial material in carbonate rocks. Based on composition, there are three main components: allochems, matrix, and cement. The Folk system uses two-part names. The first refers to the grains and the second is the root. It is helpful to have a petrographic microscope when using the Folk scheme, because it is easier to determine the components present in each sample. Dunham Classification. The Dunham scheme focuses on depositional textures. Each name is based upon the texture of the grains that make up the limestone. Robert J. Dunham published his system for limestone in 1962. It focuses on the depositional fabric of carbonate rocks. Dunham divides the rocks into 4 main groups based on relative proportions of coarser-clastic particles. Dunham names are essentially for rock families. His efforts deal with the question of whether or not the grains were originally in mutual contact, and therefore self-supporting, or whether the rock is characterized by the presence of frame builders and algal mats. Unlike the Folk scheme, Dunham deals with the original porosity of the rock. The Dunham scheme is more useful for hand samples because it is based on texture, not the grains in the sample. Limestone Landscape. Limestone makes up about 10% of the total volume of all sedimentary rocks. Limestone is partially soluble, especially in acid, and therefore forms many erosional landforms. These include limestone pavements, potholes, snouts, caves and gorges. Such erosion landscapes are known as karsts. Limestone is less resistant than most igneous rocks, but more resistant than most other sedimentary rocks. It is therefore usually associated with hills and downland, and occurs in regions with other sedimentary rocks, typically clays. Karst topography and caves develop in limestone rocks due to their solubility in dilute acidic groundwater. The solubility of limestone in water and weak acid solutions leads to karst landscapes. Regions overlying a limestone bedrock tend to have fewer visible above-ground sources, as surface water easily drains downward through joints in the limestone, while draining water and organic acid from the soil slowly enlarges these cracks, dissolving the calcium carbonate and carrying it away in solution. Most cave systems are through limestone bedrock. Cooling groundwater or mixing of different groundwaters will also create conditions suitable for cave formation. Coastal limestones are often eroded by organisms which bore into the rock by various means. This process is known as bioerosion. It is most common in the tropics, and it is known throughout the fossil record. Bands of limestone emerge from the Earth's surface in often spectacular rocky outcrops and islands. Examples include the Burin in Clare, Ireland, the Verdon Gorge in France, Malin Cove in North Yorkshire and the Isle of Wight, England, on Faroe near the Swedish island of Gotland, the Niagara Escarpment in Canada, United States, Notch Peak in Utah, the Ha Long Bay National Park in Vietnam and the hills around the Lijiang River and Guilin City in China. The Florida Keys Islands off the south coast of Florida are composed mainly of oolitic limestone and the carbonate skeletons of coral reefs, which thrived in the area during interglacial periods when sea level was higher than at present. Unique habitats are found on alvars, extremely level expanses of limestone with thin soil mantles. The largest such expanse in Europe is the Stora Alvaret on the island of Åland, Sweden. Another area with large quantities of limestone is the island of Gotland, Sweden. Huge quarries in northwestern Europe, such as those of Mount St. Peter, extend for more than 100 kilometers. The world's largest limestone quarry is at Michigan Limestone and Chemical Company in Rogers City, Michigan. Uses. Limestone is very common in architecture, especially in Europe and North America. Many landmarks across the world, including the Great Pyramid and its associated complex in Giza, Egypt, are made of limestone. So many buildings in Kingston, Ontario, Canada were constructed from it that it is nicknamed the Limestone City. On the island of Malta, a variety of limestone called Globigerina limestone was, for a long time, the only building material available, and is still very frequently used on all types of buildings and sculptures. Limestone is readily available and relatively easy to cut into blocks or more elaborate carving. It is also long-lasting and stands up well to exposure. However, it is a very heavy material, making it impractical for tall buildings, and relatively expensive as a building material. Limestone was most popular in the late 19th and early 20th centuries. Train stations, banks and other structures from that era are normally made of limestone. It is used as a facade on some skyscrapers, but only in thin plates for covering, rather than solid blocks. In the United States, Indiana, most notably the Bloomington area, has long been a source of high-quality quarried limestone, called Indiana limestone. Many famous buildings in London are built from Portland limestone. Limestone was also a very popular building block in the Middle Ages in the areas where it occurred, since it is hard, durable, and commonly occurs in easily accessible surface exposures. Many medieval churches and castles in Europe are made of limestone. Beer stone was a popular kind of limestone for medieval buildings in southern England. Limestone and marble are reactive to acid solutions, making acid rain a significant problem to the preservation of artifacts made from this stone. Many limestone statues and building surfaces have suffered severe damage due to acid rain. Acid-based cleaning chemicals can also etch limestone, which should only be cleaned with a neutral or mild alkaline-based cleaner. Other uses include: it is the raw material for the manufacture of quicklime, slaked lime, cement and mortar. Pulverized limestone is used as a soil conditioner to neutralize acidic soils. Is crushed for use as aggregate, the solid base for many roads as well as in asphalt concrete. Geological formations of limestone are among the best petroleum reservoirs. As a reagent in flue gas desulfurization, it reacts with sulfur dioxide for air pollution control. Glassmaking, in some circumstances, uses limestone. It is added to toothpaste, paper, plastics, paint, tiles, and other materials as both white pigment and a cheap filler. It can suppress methane explosions in underground coal mines. Purified, it is added to bread and cereals as a source of calcium. Calcium levels in livestock feed are supplemented with it, such as for poultry. It can be used for remineralizing and increasing the alkalinity of purified water to prevent pipe corrosion and to restore essential nutrient levels. Used in blast furnaces, limestone binds with silica and other impurities to remove them from the iron. It is often found in medicines and cosmetics. It is used in sculptures because of its suitability for carving. Occupational safety and health. People can be exposed to limestone in the workplace by inhaling it in eye contact. The Occupational Safety and Health Administration has set the legal limit for limestone exposure in the workplace as 15 mg per cubic meter total exposure and 5 mg per cubic meter respiratory exposure over an 8-hour workday. The National Institute for Occupational Safety and Health has set a recommended exposure limit of 10 mg per cubic meter total exposure and 5 mg per cubic meter respiratory exposure over an 8-hour workday. Degradation by organisms. The cyanobacterium Hyalobalanine can bore through limestone, as can the green algae Eugalmans schizaculator and the fungus Ostracolaba implexa. Gallery. A stratigraphic section of Ordovician limestone exposed in central Tennessee, U.S. The less resistant and thinner beds are composed of shale. The vertical lines are drill holes for explosives used during road construction. Thin section view of a Middle Jurassic limestone in southern Utah, U.S. The round grains are ooids. The largest is 1.2 mm in diameter. This limestone is an eusporite. Photo: an etched section of a sample of fossiliferous limestone from the Cope Formation near Cincinnati, Ohio, U.S. Biosperite limestone of the Brassfield Formation near Fairborn, Ohio, U.S., showing grains mainly composed of crinoid fragments. A concretionary nodular limestone at Jinchuan Coastal National Geopark, Dalian, China.